Hey everybody, Milk's here.
And MoNaCo too.
Ooh, new unit.
New unit, 7 solutions. In this second half, in the second semester of the year, we're picking up the pace.
Yes, we are.
And the units are going to be smaller, but there should be more reviews of previous science topics that you've already studied in other classes.
Could be, yeah.
In many cases.
Yeah, but we're going to go a little bit more in depth into specific areas
Right.
now, instead of that whole grand
Big picture stuff. We're
that we were
going
doing
into
earlier.
minute details we're going to focus on.
Yeah.
So. This is page 3 for your packet. The first unit video is about the objectives and what you need to know. These are the I needs to knowses.
Yeah, we're going to learn all of this stuff at some point throughout the unit.
Right, so start here.
Yeah, help familiarize ourselves with some of these words, right?
Solutions and solubility. What do we got here?
First one, differentiate between heterogeneous and homogeneous mixtures.
Geez, wasn't that part of our first unit of the year? Homogeneous and heterogeneous?
Yes, it was. Differentiate.
Means tell the difference between
There you go. Heterogeneous
They all aren't the same throughout.
and homogeneous.
Looks the same throughout. Hey, I did it.
You did it.
Moving on. So identify the various types of heterogeneous mixtures and their properties. There's no heterogeneous mixtures, there's homogeneous mixtures and their properties. So, colloids, oh, that's right. There are mixtures that are not the same all the way through. They're colloids and suspensions.
There you go.
Yep. So,
And there are some that are the same all the way through, and those are called alloys and solutions.
right. And so those are our main focus this unit is the solutions.
The solution piece
Right.
specifically.
So we're really going into depth on what that is
Right, so we'll give you a little bit of background about what all of them are. I mean, there's definitely some
and what the
possibilities.
Yep. And then we're going to go into the details about the reference tables that deal with solutions and all the things that we know.
Right. So now we need to define solubility and understand the factors that are going to contribute to said solubility.
Right, like what does it mean to be able to dissolve? And
Right.
what can you do to speed it up, slow it down, change it, not change it?
Right.
What can you do?
And well, this unit isn't so much about rate for us.
No.
It's just more about how much.
It's more about the nature of the
Yeah.
materials.
How can I make more dissolve?
Yeah.
Rather than just the rate. So nature of solvent.
Right.
You're going to hear this a lot. Like dissolves like. You want to tell
Right.
us about that real quick?
Sure. It's basically a really easy rule to follow that'll help you decide if a compound will dissolve in water or not.
Okay.
Or if something does dissolve in water, why?
Right.
Or if something dissolves in oil, why? This is the why. Why does this dissolve in that? Or why does this not dissolve in that?
Right.
Like dissolves like, we'll explain what that means when it's dealing with the
Right.
nature of the solute.
Right. It means really polar dissolves polar and non-polar dissolves non-polar.
Yep.
Like dissolves like.
And we'll understand how temperature plays into that,
Yep.
for sure.
And then we're going to figure out what a precipitate is.
And if it is forming in a chemical reaction. So a precipitate is like an insoluble thing. It's like something that won't dissolve in water.
Right.
And it falls to the bottom of test tubes when it forms.
Just like how the rain falls.
So the common word is precipitate, but in chemistry it means different
Yes.
than what it did in earth science. Earth science it meant snow and rain and sleet falling from the sky
And here it's solid falling out of solution.
into the bottom of
Correct.
the test tube. Yeah.
Yep. Okay, good.
So there's 3 types of solutions. We'll talk about them using a reference table: saturated, unsaturated, and supersaturated solutions. They're very important terms to focus on.
Yep. And be able to differentiate between them, of course. We're going to differentiate between dilute and concentrated solutions.
In both a particle model, like a visual identification, like, if this was concentrated, would it be light or dark? Versus also, here's a number that represents the measurement of a concentration.
Right,
Is that diluted or is that concentrated?
Which one is more concentrated?
This number versus that number. Obviously, the bigger number is going to be more concentrated, but you got to know.
But it's per volume too.
Right.
So,
Dilute and
packet-
concentrated,
right,
simple enough.
right, a packet of Kool-Aid in the swimming pool is not going to be very concentrated.
Very diluted, I would say.
Right, compared to a packet of Kool-Aid inside of my little pitcher of water.
Your 16-ounce bottle of water.
Right.
It's almost too concentrated.
There you go.
So we're also going to use the maths that we have to break out here.
Just a little bit of algebra.
Algebra, brah.
Brah.
Brah, bro. We're going to do molarity and parts per million, as well as we're going to bring back a little percent mass and a little percent volume, maybe.
Right.
Okay.
And the molarity is good because that's going to bring us a little bit into the GFM and moles. So a little bit of review from moles.
So there's a new way to measure concentration. It's in this unit called molarity.
That's going to be the big one. And
Percent mass and volume we're going to skip mostly because it's part divided by whole times 100. We've been doing it since day 1, figuring out our
Right.
test scores. Like,
Right.
seriously?
It's not that complicated. We're going to touch on it quick. And
Yep.
The parts per million is used for very, very low concentration.
Dilute solutions.
Yeah.
Right.
And then we're going to use this molarity so you can prepare a solution of a known concentration.
Right. You're going to know how to use that calculation to say, okay, well, I must need this many grams of my solute, and I have to add it to this many milliliters of my solvent to make this concentration.
And this is exactly what MoNaCo and I do when we got to make solutions for you guys in lab. Like we want it to be safe, so we want a certain concentration. We know how much of it we need. Right. We can do all that back calculating to figure out how much powder to pass
I need to
out.
make, 5 gallons of this stuff, or maybe I'll need to make 50 milliliters. Who knows? We got to do the calculations that we just showed you.
There you go.
This is cool. Colligative properties. Everybody asks, is this the unit we're going to make ice cream, Mr. MoNaCo?
If it's, we're gonna.
We're going to. We might have to buy ice if the weather doesn't hold still.
Normally we have lots of snow to do this.
But the whole reason why we would even make ice cream is so we can explain a solute's effect on a solution. So what does adding salt do to the water and the ice?
Right, that'd be the colligative properties. That's going to be cool that we can do that.
Right, so that's kind of the end of the unit.
And that math is all gone.
There used to be math associated with it.
You can actually calculate what the new temperature
should be. How many degrees per mole?
That stuff's all gone, so you guys are lucky there. So these are the two pieces. We got freezing point depression and boiling point elevation.
The freezing point depression is where we'll do the lab as a class.
Correct, and here the piece that students get confuzzled a little bit about this is that both are happening simultaneously.
But you're only ever looking at one of the two at once.
Right, because I can never be at the boiling point
and the freezing point at the same time. Not in the same.
So both happen instantly, but I'm only at one side of the spectrum, if you will, at a time. So
for sure.
So that's it, guys. Keep an eye out for each of these topics as we go through, and by all means, feel free to check them off as you master each of them.
Yeah, and you're going to see all those vocabulary words again.
Oh, yeah.
So.
Oh, yeah.
Thanks, and, pick up the pace. Let's go.
Here we go. Hey, matter of fact, watch the next video. See ya.